We really need to talk about the hangover after the AI party.
Oh, man. The morning after is always rough.
It really is. Because, for the last year or so, it's just been all about the agent.
Right. Everyone is building them.
Exactly. You've got agents writing code, agents booking travel, agents analyzing quarterly reports.
It feels like the golden age of automation.
It does. Until you actually try to put one of these things into a production environment.
Yes.
Then you get that morning after headache I'm talking about.
Because it works perfectly on your laptop.
Right.
But then it absolutely sets the server on fire when you put it in production.
Exactly that. You build this demo, and it looks like pure magic to the executives.
Oh, they love the demos.
They love them. But then you scale it up, and suddenly you realize that your magic is really just a statistical probability of being right.
And sometimes statistics work against you
Yeah.
very aggressively.
Yeah.
That's the reality gap, really. We are very, very good at building prototypes that wow stakeholders. We are significantly less good at building systems that don't, embarrass us at 3 in the morning.
Which brings us to today's deep dive. We are looking at a really fascinating piece by Aaron Rose.
Right, published on tech-reader.
Yeah, it's called The Judge and the Jury, Automated Azure Evaluation Loops. And honestly, reading it, it felt less like a technical tutorial and more like, I don't know, a therapy session.
A support group for engineers.
Exactly. For anyone who's actually tried to orchestrate LLMs. So our mission today is to figure out how we move from a system that sort of works to one that is actually production ready.
Which means we are targeting the single biggest bottleneck in AI engineering right now.
Trust.
Trust. How do you trust a probabilistic system to do a deterministic job without just, manually checking its work every single time?
And the answer definitely isn't just hope.
No. Hope is rarely a good software architecture strategy.
So Rose centers this whole piece around a scenario involving a developer named Timothy. And I don't even think Timothy is a fictional character. He feels more like a composite of literally every engineer I've talked to in the last 6 months.
Oh, absolutely. We've all been Timothy.
He's standing at this whiteboard with his architect, Margaret, and they are just staring at a system that is technically working.
Technically.
Right, technically. But it's failing just enough to be completely useless.
Which is honestly the worst kind of failure.
How so?
Well, think about it. If a system crashes 100% of the time, it's easy to fix. You find the bug, you squash it.
Yeah, that makes sense.
But if it crashes, say, 5% of the time...
And you don't know which 5%?
Exactly. You can't deploy that. It's a liability.
So specifically, in this article, Timothy's dealing with this chain reaction of failures. And I really want to drill into this detail because it perfectly illustrates where the agent model breaks down.
Let's do it.
So he has this extraction agent.
Okay.
And its only job, its entire purpose in life, is to pull specific fields from an email or a document. Sounds incredibly simple, right?
In theory, yes.
But occasionally, the AI model just decides to skip a field.
Right.
Maybe the phrasing in the email was a little weird, or maybe the temperature setting was slightly too high. Who knows?
It just misses it.
Yeah, it misses it. So the extraction agent passes a null value down the pipeline.
And here comes the chain reaction. Because the next agent in line, the inventory agent, it has no idea that a mistake was just made.
None at all.
It just sees null and thinks, well, I guess I'm logging a null entry into the database today.
And boom, just like that, you have corrupted data. But the crazy part is, the system didn't throw an error code.
No.
The API returned a 200 OK status. Everything looks perfectly fine on the surface.
But underneath, your database is just slowly filling up with absolute garbage.
Yes. Margaret calls this the black box problem. Timothy puts an input in, he gets an output out, and unless he is manually reading the logs for every single execution...
Which is impossible.
Literally impossible. He has no idea if those intermediate steps were actually correct.
Which brings us to the core conflict of the piece. Timothy tells Margaret, I can't sit here and manually check every trace.
And he's totally right.
He is. But you also can't just let the system run wild and corrupt your database.
Right. So Margaret gets up, goes to the whiteboard, and draws a box. And she labels it the evaluation loop.
This is the big paradigm shift, moving from manual spot checking to automated auditing.
Okay, let's talk about how that actually works, because it relies on a concept that Rose says is becoming standard in the industry.
LLM as a judge.
Yeah, LLM as a judge. Now, let's pause here for a second, because LLM as a judge sounds amazing in a blog post.
It does.
But as someone who looks at cloud bills, my wallet just clamps shut. You are telling me that to fix my expensive AI agent, I need to run another expensive AI agent just to grade it.
It is a very valid concern because you are effectively doubling your token count, or at least increasing it significantly.
Yeah.
And you are adding latency. If you have a user sitting there waiting for a response, adding an entire judge step slows everything down.
Right, so why on earth would I do that?
Well, because the cost of bad data is ultimately higher than the cost of compute.
Okay, fair point.
But Margaret's argument and Rose's argument in the source material is that you don't necessarily use the same model for the judge.
Oh,
You
interesting.
use a tiered approach. Your worker agents, the ones doing the grunt work of extraction, those might be smaller, faster, cheaper models.
Like a GPT 3.5 or an open source model.
Exactly. They optimize for speed and throughput, but your judge needs to be the smartest model you can get your hands on.
Ah.
You bring in the GPT-4 class model, the heavy hitter, specifically for that evaluation step.
So it's literally like having a teacher who is smarter than the student grading the homework.
Precisely. And the judge sits entirely outside the main workflow. It doesn't modify data initially. It just observes the input the worker received and the output the worker generated, and it scores it.
Okay, but how does it score it? Because this isn't math. You can't just check if X equals Y. We're dealing with natural language here.
Right, and this is where a lot of early implementations completely fail. People just prompt the judge with something like, is this good?
Does this vibe check out?
Exactly, and the judge will just say, sure, looks great to me. That's useless.
You need a rubric.
You need a highly structured rubric. Rose breaks this down into two very specific industry standard metrics, faithfulness and relevancy.
Let's walk through those because they sound similar, but they are very different things. Walk us through faithfulness first. To me, that just sounds like, did the AI tell the truth?
Ideally, yes. But in these systems, particularly retrieval-augmented generation or RG systems, faithfulness has a very specific meaning.
Okay.
It means, is the response supported by the retrieved context? It is strictly a hallucination check.
Give me an example.
Sure. If the source email says the client wants a refund and your extraction agent outputs the client wants a replacement, that is an unfaithful response.
Got it. Okay, but let me throw a gray area at you.
Go for it.
What if the email strongly implies they want a refund, but they never actually use the word refund? If the agent infers it, is that a hallucination?
That right there is the million-dollar question in AI engineering.
Yeah.
And that is exactly why your rubric has to be incredibly detailed. You cannot just give the judge a prompt that says check for truth.
Right.
You have to write a system prompt that says you are a critical auditor. Grade the response on a scale of 1 to 5 based strictly on how it adheres to the provided text. Do not allow logical leaps that are not present in the source.
Wow. So you're essentially programming the judge to be a massive pedant.
You have to be pedantic because the alternative is chaos. And that brings us to the second metric, which balances it out. Relevancy.
Relevancy.
Relevancy asks, did you actually answer the user's question?
Okay, so how does that differ from faithfulness?
You can be 100% faithful. You can quote the source text perfectly without making anything up. But if the user asked for a bulleted summary and you gave them a 3-page direct quote, you failed relevancy.
I see. So going back to Timothy's extraction agent, it might have been perfectly faithful because it didn't invent a fake zip code.
Right.
But it failed relevancy because it completely ignored the zip code that was sitting right there in the text.
Precisely. It didn't do the job it was asked to do. So the judge evaluates these specific criteria based on the rubric, and it assigns a pass or fail grade.
Okay, so now we have a report card. The judge comes back and says, hey, Timothy, your agent failed 15% of the time today.
Which is hopeful.
It's better than not knowing. But Timothy is still having a bad day. He still has to go manually fix that 15% of corrupted data.
And that is why detection is really only half the battle here. Margaret's diagram on the whiteboard has another crucial component.
The self-correction loop.
Yes, the self-correction loop. This is the moment we move from having a human in the loop to having a system in the loop.
I have to admit, this is the part of the source material that felt a little bit like sci-fi to me. The idea that the system just fixes itself.
It feels magical, but it's really just recursive prompting. It's a very logical flow.
Walk me through it.
When the evaluator, the judge, spots an error like that missing zip code we talked about, it doesn't just log the error and give up.
Right.
It generates a correction prompt. It actually sends the bad output back to the orchestrator along with very specific feedback.
Like, hey, you missed the zip code, try again.
Exactly. It says to the worker agent, you missed the zip code, look at the source text again and extract the zip code this time.
So the agent gets a do-over.
It gets a retry. And the beauty of the closed loop is that it keeps retrying until the judge finally gives it a passing score.
Okay, hold on, though. I am thinking about the user experience here.
Sure.
If I am the end user and I click Submit on a form, and the system enters this recursive loop behind the scenes,
Yeah.
am I just sitting there staring at a loading spinner while these two robots argue with each other?
You might be.
Yeah.
That is the fundamental trade-off of this architecture. You are trading latency for reliability.
Right.
Now, if this is a background process, say you are batch processing 1,000 invoices overnight, that extra 10 or 20 seconds of looping doesn't matter at all.
Sure, nobody cares.
But in a live customer service chat, it might matter a lot. You have to design around that delay.
Also, what prevents an infinite loop?
What do you mean?
Well, what if the worker agent is just, for lack of a better word, dumb? And the judge keeps saying, fix it, and the worker keeps confidently getting it wrong over and over again.
That happens, and you need an exit hatch for it. You always set a maximum retries parameter.
Okay.
Usually you give the agent 2 or 3 shots to get it right. If it still fails the judge's root work after 3 tries, then and only then do you flag it and send it to a human.
I see. So the human's role completely changes. They become the exception handler, not the routine quality control officer.
Exactly. Timothy goes from having to manually check 100 logs every morning to only checking the 3 logs that were just too weird for the AI to figure out.
That is a massive productivity shift.
It changes the entire architecture from a straight line. Input to output into a process. Input to draft, to critique, to revision, to output.
Which, if you really think about it, is exactly how humans work.
Yes.
We don't just blurt things out. Well, most of us don't. We draft something in our heads, we review it, we self-correct, and then we speak.
We are effectively giving the software a thinking phase.
I love that.
Oh.
But I want to pivot to the implementation side of this for a minute. Because we've talked about the judge and we've talked about the loop, but Timothy asks a question in the article that really hits hard.
Oh, I know the one.
He asks, how do I know the judge is right?
The classic who watches the watchman problem.
Exactly. Because if I'm using GPT-4 to grade GPT 3.5, GPT-4 is still an LLM. It can still hallucinate. It can still have weird biases. If my ruler is bent, all my measurements are going to be wrong.
And this is where we have to leave the fun, creative world of prompt engineering and enter the grueling, tedious world of actual data science.
Oh, boy.
You need ground truth.
Ground truth. It sounds so absolute. But in practice, what does that actually look like for an Azure setup?
Honestly, it looks like a spreadsheet.
Just a spreadsheet.
A very carefully curated, manually verified spreadsheet. Rose refers to it in the piece as the golden data set.
See, golden data set implies it was handed down from the heavens on stone tablets. But someone actually has to build this thing, right?
And that is, without a doubt, the hardest part of this entire process. You cannot automate the creation of the golden data set.
You can't just have an AI write it.
No, because then you're back to trusting the AI blindly.
Yeah.
You need human experts, real subject matter experts.
Right.
They have to look at a representative set of inputs and manually write down exactly what the perfect, flawless output should be.
So if you are building, say, a medical diagnosis bot, you need actual practicing doctors to sit down and write the answers for this test set.
Yes. And let me tell you, they will disagree with each other.
Oh, I bet.
And you have to resolve those disagreements. It is incredibly time-consuming. But once you have that data set, say 100 perfectly solved examples, you finally have your anchor.
Okay, so how do you use this anchor?
Yeah.
You aren't running this golden data set live in production, surely.
No. This is strictly for testing and regression. Think of it like a unit test.
Okay.
Before Timothy deploys a new version of his system prompt, or before he decides to switch to a cheaper model to save money, he runs the entire system against this golden data set.
It's a semantic unit test.
Exactly. He compares the agent's new output to the established ground truth, and you get a system grade.
Right.
If the baseline accuracy score was 95% last week, and he tweaks a prompt and it drops to 82%, he immediately knows he broke something.
This is so crucial because fixing a prompt in a vacuum is so incredibly dangerous.
It's terrifying.
You tweak it to be a little friendlier to the user, and suddenly it entirely forgets how to understand dates.
That happens all the time. It is called model drift or regression.
Yeah.
Without a golden data set, you are just relying on vibe checks. You run a few manual prompts, they look okay on your screen, and you hit deploy.
And hope for the best.
Right. But with the data set, you have a hard, objective metric. You can look at a dashboard and say, this exact change caused a 4% drop in faithfulness.
So the golden data set validates the worker agents. But wait, does it validate the judge too?
Yes. And this is the step that almost everyone skips.
How does that work?
You run your judge against the dataset as well. You ask the judge to grade the human-verified perfect answers.
Oh, that's smart.
If the judge looks at a perfect answer and gives it a failing grade, you instantly know your judge is broken.
Or your rubric is just too ambiguous.
Exactly. It forces you to refine your definitions. If the human expert says this is a pass, but the judge says this is a fail, you have to sit there and tune the judge's system prompt until its grading aligns perfectly with the human's judgment.
That makes total sense. So we're really talking about building a hierarchy of trust here.
Very much so.
The worker agent trusts the judge. The judge trusts the rubric. And the rubric is constantly calibrated against the golden data set, which was meticulously created by human experts.
Correct. Ultimately, the bedrock source of truth is still human expertise.
Right.
We aren't replacing the human. We are just finding a way to scale the human standards across millions of executions.
I really like that framing. Scaling standards.
Yeah.
Because that is really what production readiness is, isn't it?
Yes.
It isn't about the system being literally flawless every time.
Yeah.
It's about it being consistently predictable.
Margaret has a line near the very end of the article that sums this up perfectly.
What does she say?
She tells Timothy, when you stop guessing and start measuring, the architecture finally becomes production ready.
Stop guessing. That is the whole takeaway.
It is. We are finally moving out of the magic trick phase of generative AI.
Yeah.
The novelty of just getting a chatbot to talk to you has worn off. Now we are in the hard engineering phase, and real engineering requires measurement, it requires logs, audit trails, and accountability.
It sounds kind of boring compared to the magic phase.
It does, but boring is what actually makes money. Boring is what keeps the server running at 3 in the morning.
I'll take a boring, self-correcting system over a magical, hallucinating one any day of the week.
Absolutely.
Now, there's one thing I want to push on just a bit before we wrap up today.
Sure.
We are banking a whole lot on this golden data set being the ultimate source of truth.
Mm-hmm.
But in the real world, systems change.
They do.
Data changes. Business logic changes. Let's say we used to extract the total from an invoice, but the finance department updates their policy, and now we need to extract the subtotal.
Then your golden data set is officially poisoned.
Poison!
Yes, because it is evaluating for the old rules.
Exactly. If you don't update that data set, your evaluation loop is going to actively fight against your new features.
It will.
It will look at the new correct subtotal, flag it as an error, and try to correct the agent back to pulling the old total.
And that highlights the massive maintenance burden of this architecture.
Mm-hmm.
The golden data set is not just a set it and forget it artifact.
Right.
It is a living document. Every single time the business requirements change, a human expert has to go back in and update the ground truth.
Because if you don't, you are building a highly efficient, automated system that aggressively enforces obsolete rules.
It's like having a middle manager who hasn't read the new company handbook and just keeps writing everyone up for following the new procedures.
And since the system is automated and runs at the speed of light, that manager is going to win the argument every single time.
Every time.
You know, that's a slightly terrifying thought to leave on. If an AI system can self-correct perfectly based on a perfect data set, what happens when our definition of perfect shifts and the AI is the only one left noticing the drift?
It comes back to the same principle we've seen in every tech revolution. There is no free lunch.
Nope.
AI doesn't remove the work, it shifts the work. It shifts it from doing the manual task to meticulously designing the criteria for the task.
And maintaining the standard of truth.
Precisely. You are managing the rules now, not the execution.
Well, this has been a really solid reality check. For everyone listening out there, if you are building agents, don't just build the bot.
Right.
Build the judge, build the jury, and for the love of code, build your golden data set.
And please keep it updated.
Thanks for diving into the logs with us today.
Always a pleasure to be here.
Catch you on the next Deep Dive.